Good morning, everyone. How's it going today? All right. In the next 50 minutes, we are going to talk about a cool experiment we did recently. So the idea is we built this real-time generative application. So what it can do is once you feed the live tennis stats into it, it can generate commentary automatically. So that means there's no human in the loop. So the idea is that it can make the sports commentary more productive with the use of AI. So that's it. So it the demo looks cool for sure, but we want to go beyond the cool demo, and we want to share the design principles and the solution design patterns that we learned during this experiment. So if you are building your next generative AI application with streaming data, you might find this talk useful. So let's begin. By the way, I'm DANUSHKA. I'm a senior developer advocate from Redpanda. And joining with me today as my co-presenter, Mark Needham.
Hey, I'm Mark. So I work in the product team at ClickHouse.
Over to you, Mark.
Right. So we are both quite fans of the BBC live text commentary because neither of us have all the different sports packages you need to be able to follow every single event actually live. So we kind of rely on the BBC live text. And they do this so we've got tennis, but they do it for cricket, they do it for football. Now they do it for darts. Now that we've got someone who's really good at darts, we do it for darts as well. And so one of the events that I was following, which we've got on the screen here, was the US Open final of 2023. And so they come up with like kind of commentary sort of like this. So that probably once a minute or maybe sometimes more frequently, depending on what part of the match it is, they'll come up with some commentary. So this would be one. So like very early on, something unusual has happened and they're like, right, we've got to capture that. They'll then have other things like this. So maybe in the middle of the game, they'll say something about a few of the points. They might then pull in some commentary that's being done. I think this was maybe somebody who was in the stadium, like giving them a quote. And then if we come over here, we can see like this is the sort of thing that they do at the end. And then they start doing like point by point. So they kind of adjust like the granularity of what sort of commentary they're doing. And some of this stuff, this is very human, right? Like the stuff they come up with sometimes, there's no way you can get an AI to come up with it. And some of it, they're just repeating, well, what happened? It's like, oh, someone did a double fault. It's like, okay, well, that's not very interesting for you to write. And so what we were thinking is, could we create an AI copilot to help the live text writer or the live text commenter? So it could be that we may so what they tend to do is they'll pick one or two matches and they'll comment on those. But there are often, like in tennis, 20 or 30 matches happening at the same time. And the other ones, they just don't say anything about them, right? They just completely ignore them because it's impossible to have enough people to do it. Maybe in other sports, like in football, there are an infinite number of matches happening. Like if you took every single league, there's probably sometimes like 50, 60 matches happening at a time. And they'll just pick two. They're like, right, we're just doing this one and this one. And if you want to follow any of the other ones, you just get like a little score thing and you're like, okay, I can see the score. So we thought, like, can we like help this process? And so this is the experiment that DUNITH was mentioning. So at a high level, what we're going to build is reasonably simple, I guess. So we've got a feed of events, which are they're very concise. They're like, this is exactly like the data that happened, but it doesn't really have anything human about it. Like if you fed that, it'd be like, okay, well, this makes sports seem really, really boring. And then what we're going to do is we're going to feed that in. We're going to sort of pull the events, like however many we feel like would be interesting to pull. We're going to feed that into a generative AI tool, and we're going to say, hey, can you take these events and generate like some commentary? And we're going to give it like some like a prompt to try and help it come up with something that we think is consumable by the user. And then finally, on the far side, we're then going to look at how would you go about broadcasting that commentary? Like how would you get that to our reader, like to the reader who's going to be looking at it? So I'm going to hand back to DUNITH for this one.
Yes, Mark. Thank you. So the diagram you see here, that's the bird's eye view of the solution. So this is the commentator's view. But if we zoom into details, this is the solution blueprint you would see. I know it's pretty early to get into these kind of details yet, and it's pretty crowded. But I just want to highlight you the flow of data in the system. So everything starts from the far left side. So we have a Python script, and then it gets to Redpanda and ends up in the web app you see here. So basically, there are a couple of technological components you may have or you may not have heard of before, particularly Redpanda, ClickHouse, OpenAI you might have heard of already, and Streamlit. So let me give you an introduction to each component before we jump into the implementation. All right, let's begin with Redpanda. Anyone heard of Redpanda before? All right, cool. Anyone heard of Apache Kafka before? All right, thank you. You made my life easier. Because Redpanda is a Kafka API compatible streaming data platform. You know, streaming data platform, as in it's a distributed, replicated event log, append only log. So basically, what you see in Kafka, you know, the critical construct like topics, partitions, segments, consumer group, rebalancing, and everything, which is identically exactly available in Redpanda as well. And you can see Redpanda is write and read compatible with Kafka APIs. So basically, this means if you already have Kafka producers or consumers, you can seamlessly migrate them to Redpanda without even writing a single line of code. And the nice thing about Redpanda is, even though Redpanda speaks the same language as Kafka, it has drastic differences in its architecture. For example, Redpanda is not yet another Kafka fork or some kind of a clone. It's a total rewrite in C++. And it's designed to make the most out of modern hardware that makes it more faster and cheaper and simple to operate than Kafka. And it's operators and developers' best friend. For example, it comes with this single binary architecture. That means if you deploy a typical Kafka cluster, you will see the broker itself, and then the schema registry, and then HTTP proxy, and then the consensus algorithm like Zookeeper. But if you spin up a Redpanda broker, you will get all these components in the single process. That's the beauty. That means you have less number of components to manage. If you spin up Redpanda, you will get broker and the schema registry, HTTP proxy, and there's no Zookeeper dependency here. So we have our own RAF algorithm implementation. So everything you will get as free. And then I said it's a developer's best friend. So you will get this web UI. We call it Redpanda console. So if you are debugging or if you are building applications, this is a cool way to look at your Redpanda cluster. For example, you can look at your message payloads here. And then you can also do some administrative tasks like creating schemas, defining security roles, and etc. We'll get more hands-on when Mark does this thing in his demo. And then we have a CLI as well, just to manage your Redpanda cluster. This is like KCAT on steroids. So we'll see this in action in a shortly. All right, let's dive into our first demo. In this demo, what we are going to do is we are going to hydrate the Redpanda first. That means we are going to simulate a live tennis match. Because the thing is, we try to invoke a live tennis feed, but the thing is, it's practically impossible to get the live match at the same time as we do.
Wait,
so
there aren't any matches right now.
Exactly, we are in the wrong time. So what we did was we wrote a Python script to simulate an actual match. So we are going to run this script now and then hydrate a topic in Redpanda. Mark, you want to?
I should say, don't worry, this is not going to be at like real life speed of a tennis match. We'll be waiting a long time. We've sped this up a bit. So we've got, let me just quickly show you. So we've got, as DUNITH said, we've got Redpanda running on my machine already. Is that big enough on the back? Yeah. So this is the Redpanda UI.
Yeah,
you can kind of see
the Redpanda console I mentioned. So
you can see we've only got one broker, so we're not. This is just on our machine. If you were running this in a production, you're going to be seeing multiple of them there. Now, what we want to do is we want to create ourselves a topic. So we can use the RPK tool that DUNITH showed, or we can do it from this UI. So our topic is going to be called points. So we're going to be capturing every point from a tennis match. So we can specify that. If we were having more Redpanda instances, we could choose our replication factor, and then we can choose how many partitions we're going to have in the data. Don't know. Would you do anything else on these? Retention
No,
time?
just leave them.
Just
as
leave those all.
defaults, yeah.
Okay, so let's create that. So the topic's created. You don't actually have to do that. If you're using the client, and as soon as it creates data, it would actually just create the topic for you. The disadvantage of doing it like that is it will generally create it just with one. So we wanted to show you, hey, look, you can have multiple partitions, which would be generally how you're setting it up. So you can see at the moment, no messages. So we've got nothing in there at the moment. If I come over to here, let me just show you what the data looks like. So we've got a bunch of JSON files like DUNITH said. So for example, hang on, let's just open it like this. So this is what an event looks like. Actually, it might be easier if I do it like this. Hang on a minute. I'll color code it so you can actually read it. So that's what one event looks like. I'll make it a bit bigger. So we scraped this from one of the live feed sites. They had like the very, very concise data. They've actually, like on the screen, they actually had a bunch of different elements, like indicating all the tiny bits of what was going on. And this, I think, is derived from those pages, but they did have this text. So we're like, okay, we'll take the text. And then you can see we've kind of put in other contextual information that would be useful. So like, what's the set score in the set? What's the score in the point after this point has happened? What's the event? What round is it in? Who's playing? What's the previous set scores? And then we've got an ID up the top. And then we've got this script, so that can, what was it called again? Publish events. So we've got this thing called publish events, and then we can pass in a file. So we can say, hey, data, was it 1402? Yeah, let's do 1402. .json. And so you can see it's going to generate these events. I think I've got this running at about 20 times normal speed. And so just in case you're curious about how you go generating data like this, so we've got like that big file of about 300 points, and we've got the timestamp of when each thing happened. And so what we're doing is we've given it like a speed up time. So we're saying run this at 20 times normal speed, and then we're using the twisted Python library, which basically lets you have an event loop. So it kind of loops through, and every 1 second we have a look. Should it publish? So we basically put a publish time on each event at the beginning. So this is just purely for generating data. Like this has nothing to do with production. And then we look, should I publish it? And every time we go through the loop and have a look at which events now need to be published, which haven't been published, and then we publish them. That's how we're doing this. And so then, like DUNITH said, we can, if we come over here, we can use our, what is that? RPK, topic, consume, points.
There we go.
So you can see the events are coming through here. So what are we up to? 29. Yeah, and then you can see they're coming through. So we are not putting data into Redpanda as fast as what it can handle. This is like a tool that can do hundreds of thousands of messages a second. So we're doing a very gentle test of Redpanda.
Probably we could show the.
Yeah, if we then come back here, so if I hit the refresh up here, do we get it? There we go.
There you go.
So now we've got our events, and so we can click on one of them. I'll zoom in a little bit.
Yeah, you can see the actual event payload. So if you are developing an application, you can check whether you are getting the right data in the right format. And there's a schema registry as well, so you can enforce some kind of a schema so that the broker can do the validation for you. So those are some nice things you can get from.
That would be
Redpanda.
what you'd be using Avro if you're doing schema registry.
Exactly.
So I'm very lazy. I just JSON everything, and then DUNITH's like, yeah, but what happens if you change one of the fields in your JSON? Then you break everything. So if you're doing something less hacky than me, probably you want to use Avro and set up your schema in the schema registry up here, and then it will sort of handle that for you. But for quickness of starting, JSON is quite good, and you can kind of see that each message is going into different partitions. So you can see we've got a couple up here in partition 0, some in partition 2. You can also filter it up here. So you can say, hey, only show me partition 0, and then you can see what's in there. What else can I do in here? I can filter it.
You can filter. You can search for a pattern. If you know the pattern, then you can quickly.
Do you know the pattern syntax? What could I do?
Let's just leave it for
Okay, we'll leave it. I've zoomed it in a bit too much.
Yeah.
Okay, so I think that was roughly what we were gonna show. We'll come back to this UI as we go through the talk because there's still some other stuff that we want to show you. But for the moment, that is enough.
Yep.
So now I want to show you the ClickHouse part of things. So what is ClickHouse? So it's an open source database. It's been worked on for a long time, but there's only been a company around it for a couple of years. You can kind of see it is basically an analytics database. So what does that mean? So in a row-oriented database like Postgres or MySQL, the data is stored in rows. So bits of data on the same row will be next to each other. And reading a row is very fast. It's like, okay, well, I know I'm going to go from the start of the row to the end. Give me everything. In a column-oriented database, such as ClickHouse, it puts the stuff of the same columns next to each other. And so what it means is that if you say select star and get me everything, that's not going to be fast. Like Postgres will be faster than that at some data volume. But if you say I want to go through that column and count how many things there are for each thing, like do a group by and a count on the number of locations, or if I want to filter it and say in Blackpool, what's the average temperature? Like if I do that type of query, that's the type of thing that ClickHouse is good at. And it uses something called vectorized query execution. So rather than processing each row sequentially, it's going to take chunks of the columns and then process those and apply any operations over them at the same time. And I guess ClickHouse's thing is that it's able to do this very specific type of aggregation queries very quickly. That's I guess its reason for being. And it interacts or ingests with a lot of different formats. So if you've got Parquet files that'll work, JSON files that'll work, CSV, NumPy, Arrow, Avro, the same as what DUNITH was showing us. We can ingest data from different streaming services. So we're going to be looking at Redpanda. Can do other databases, some sort of vague read support for the lake houses, and then the various bucket storage tools as well. And then this is something that I didn't know until about 6-7 months ago, is that there are different flavors of ClickHouse. So we're going to be showing you ClickHouse server. So this is the most common one. So it's kind of the common pattern. Create a server. I'm going to have my client. It's going to interact with it. But there is also a version of ClickHouse that you can use more for ad hoc analysis. So it's a CHDB. That's a Python library sort of around the ClickHouse engine. And then there's ClickHouse local, which is kind of like a CLI that you can just run on your command line and get the sort of ClickHouse querying capability and just point it at files and do stuff like that. So let me just show you. So our demo of this bit is going to be, well, how do we get those events that we've already got into Redpanda into ClickHouse so that we can do some querying on them? So I'm just going to, this one has got a bit more code, so I'm just going to copy it from my cheating page. So what we've got here, I'll make it a bit bigger in a sec. So we're going to we need to first, I think that's in the right place, yeah. So we need to start up our ClickHouse server, so let's do that.
That's your local instance.
So this is again on my machine. And we should say with both of these tools, with Redpanda and with ClickHouse, there are hosted services. There's this ClickHouse Cloud, and then there's Redpanda Cloud and Redpanda Serverless as well. So if you were needing to deploy it somewhere, you would be able to take this code, and with just a few changes, so instead of using localhost everywhere, you would then be able to deploy this somewhere so that not only the people in this talk can have a look at what you've built. So if I come over here, so what page is this on? Let me just, hang on. Yeah, so I'm going to launch my client now. Oops, just put a hyphen in there. So what I'm going to do is I'm going to create myself a table. So this is going to be one that effectively just mirrors everything that we've got in the events that we've got in Redpanda. So you can see that if you remember maybe we put the, so if you remember what the data looks like, put that on that side. Oh no, I can't see it, can I? Oh, there we go. So you can see we've got match ID, we've got ID, time, player. We're just matching those. And then for previous sets, we use an array, but everything else, pretty much a string. Okay, I'll just zoom that down now. And so that's how we're going to create a table called that. And it's going to be we call it a Kafka engine table. So it's effectively like a consumer group around Redpanda. And you can see we're pointing it at the points topic, and then we're giving it the name of a consumer group. And we'll create that. And that doesn't actually do anything. It's just kind of almost configured the metadata for it. What we need to do next is create ourselves a table where that data is then going to go. So if I just come back here, so we're going to create ourselves a table. we're gonna use exactly the same fields. Now again, you could choose if you decided actually I don't really care about some of the fields in here. You could just exclude them, and then it won't keep them. This is creating just a single quite wide table in ClickHouse. You need to specify an engine when you create it, or actually you don't actually. Now I think from the latest version you could just exclude the engine. The default engine is it appends everything on the end, but there are other ones that you can specify that it will kind of eventually upsert, so it will like eventually replace things based on a key, but we're just going to do a simple one. And a way that I quite like to think of a ClickHouse table is it's almost like a sortable, very wide spreadsheet of stuff. And so the key, depending on what queries you're going to do, that depends on how you're going to sort the data. So for us, we know that we're going to be doing things based on filtering by the match. So we want to put all the events for a match near each other so that when it comes to getting that data, we can get it quickly rather than having to scan through everything. Although, as I say, the amount of data that we're going to be putting into either of these tools is so small, it won't make any difference. But just to keep in mind when you're doing something for real. So again, we've created that table. At the moment, still no data. And that leaves us to our last step. So what we need to do for the last step is create a materialized view that's going to take the data from our consumer around Redpanda and put it into our ClickHouse table. So a materialized view in ClickHouse is slightly different than what it is in other tools, like in Postgres or in Materialize or any other tools like that. So it doesn't actually store data itself. The way to think of it is it's effectively like a trigger that's going to run some code on the incoming rows. And it can be on one incoming row or it can be on multiple. It just depends how many come in. So in fact, imagine we've got our Redpanda rows that are going to come in. And it's going to then run this code. It's going to be, OK, I'm going to select whatever was in the points topic. It's then going to do a little bit of parsing on. So this is the replace syntax. Effectively says, in that select star, I want to replace one of the fields. So all it's doing is just making it into a date time, the published time, and then it's going to basically read all that data into points. And then if a new message comes in from Redpanda, it's going to effectively run this trigger again. And so what we should be able to do now is we can say select star from points. Oh, and we've got the data in. Hang on. So just to make this a little bit easier to read, we can actually set format vertical. So we'll just limit it to one row just so you can see what's going on. So that's one of the messages that was in Redpanda. So you can see this was, I don't know which point was this. This is like point number 11. And so it's then converted that JSON. Oh, I should have said, yeah, that was the last bit that I didn't point out. So we did specify that the data coming in was going to be JSON. And then the last thing that we need to do is we need to create our matches table. So we've got this. Let me just show you what it looks like. I've just made a little table which has, or have I not? No, maybe I haven't. Hang on. Let's just put the data in the right place.
And Mark, one thing to mention here is that ClickHouse can ingest data when it arrives in Redpanda. That means there's no need of batch loading into ClickHouse. So it can ingest data on the fly. So that's what we call it, some kind of a streaming database. So yeah. Mark.
So we've pulled out this is the metadata for 5 of the matches from that tournament. So what we're going to do is just going to put that into ClickHouse as well. I'm going to create another table called matches. We're going to use again. It doesn't really matter. There's only five records, but we're then going to create that data in there. So if we then say select star from matches, then we've got the matches. Okay, so that is ClickHouse. So we've got our script. We had these raw events. We're sort of iterating through those, putting them into Redpanda, and then we've just set up ClickHouse with our Kafka engine, our materialized view, and then putting it into a table. And so now we've got the data ready to do something with it. So let's just quickly come back here and remind ourselves what we're going to do. So we could, if we want to build a front end, DUNITH and I have 0 front end skills.
Yeah.
If you have front end skills, you probably can write your own application to do this next bit. But since we don't, we use this tool called Streamlit, which is really helpful for building little POCs or just little prototypes where you want to show someone something without having to go and build out a massive application and spend all your time trying to remember how on earth do you write React after you haven't done it for a year.
Right.
So Streamlit allows you to write code in Python, so you don't really need to do any front-end stuff, and it effectively builds you a shareable web app in, I mean, it says in minutes. Obviously, that's like if you do a really, really simple one. This took more than a few minutes for us to make. But all the code that we're showing you here, well, at the end, we'll have it available for you. So you don't need to remember anything that we're doing. But this is what it looks like, a really simple Streamlit app. You say import Streamlit as ST, import pandas as PD. You can write to the screen. You can write in Markdown if you like. We can then choose to read in the file and create a line chart, right? That's the simplest thing you could do. So all of the stuff that we do is kind of building on this rough idea. So let's have a look at how we'd go about building our AI Copilot. So remember, DUNITH showed us this picture with the flow of events right at the beginning. So what we've done so far, so we started over here, remember, with our sports data feed. We got that into Redpanda. We then real-time ingested it into ClickHouse, and that's as far as we've got so far. What we're going to do in this next bit is kind of down here, this bit here. So I'm going to show you a Streamlit application that's going to pull events out of ClickHouse, generate some commentary, and put it back into Redpanda. So that's this next part of the demo.
Yep.
So let's do that. So I've got, remember which tab is, okay, so I think this tab is good. There's nothing on here, so let's run our next app. So this is called the commentator. I'm just gonna, let's run it. So if we come over here, actually, hang on. Every single time I forget to put my OpenAI key. So I think, I might have done it already, but let's not take any risks. Okay, let's have a look.
So we are going to invoke OpenAI model in the background. So that's why he mentioned about OpenAI key. So you need to have an OpenAI API key just to get this working.
So imagine that this is we call this the live text commentary admin center. I'm sure the BBC commentators have something a bit better than this, but this is my very limited UI design skills. So imagine they've got like a bunch of matches, and they can choose, like, imagine they want to write some sort of text entry, and every single time it has some sort of title and then some text. I'm sure they have more stuff than this on the page. They can go, hey, I want to pull in that commentary in here. I want to get some stats that the stat person's told me. But for the simplicity of this demo, imagine we've got this screen here. And I say, I don't know, let's say Zverev wins or something. It was a great match. No, I can't type. And let's hit publish. So you can see it says your message is published. What does that mean is if we come over to Redpanda, it's in here.
There we go.
So that's what that's like imagine that's the manual version of the commentators here, and they're watching the match on the screen maybe, and they're like, okay, what happened? Let me quickly write it up. And so what we do every single time, we're putting the live commentary into Redpanda so that it can be consumed by however many consumers we want, right? Like it could be, as DUNITH said, it could be a feed serving it, or maybe we're then taking those messages and generating like tweets. Like maybe we could write a tweet, Zverev wins, what a great match, or something like that. Now, what we were thinking while we were doing this was that it's quite like you've got to kind of start from scratch every time. So I thought like, let's have a generate with AI button. And so what you can do is you can say, we've only done 2 versions of this, but you can imagine you could probably extend this. So the most repetitive thing that they seem to do is at the end of the game, they tell you what happened in the game. So we're like, okay, well, let's get the last game. We'll pull the events from that game. We'll send it to the LLM, and we'll see what it comes up with. So let's see what it comes up with for this one. So there we go. So that's what it came up with. So Zverev and Sinner are slugging it out in an extreme 5-set showdown. I mean, it's a little bit high. It's a little bit hyperbolic, but I think we could probably play with the prompt a little bit to calm it down. Zverev turns the score around with an ace, pulling a surprise victory with a score set. I mean, it's all right. And if we decided we like it, we can put it in there. Grammarly's not happy with it, so we might then choose to go and edit it.
Yeah.
And then we could publish that event as well. And if we come over to Redpanda, we've got that event in there too.
That's a different topic, isn't it, Mark?
Yeah, so this
That's
is on a new
Other-
topic. So this is on the live text comments,
Yes.
live text topic. So the other one was points. And we could just to let's run another commentary. So that was 1402. Let's do a different one. So I can't remember what the matches are called. Hang on a minute. So matches. So Jared Djokovic is 13-16. So let's do that one. So if we run that one, so you can see it's generating some events. So we can give it, let's give it a, at least let it put in a few events. And then if I come over here, back to the app again. So if we go, let's just change that to Djokovic. And then what we could say, so let's delete this, is we could say, give me the last 5 minutes. I think this actually lasts 1 minute, but my label on there is not great. So there we go. Match kicks off with a surprise as Jera snags the first game off Djokovic in a stunning break. I mean, again, it sounds extremely American. We probably need to Britishize it a bit. Like, just calm down. You're getting a bit excited about one game. And then we could choose like Jera breaks in the first game. And so we could publish that, and then maybe a few more minutes go by, and we're like, okay, let me get another summary. And you can imagine maybe we could extend this. So we've just done like the sort of POC version of this, but something that DUNITH was suggesting is, well, all those things that it's generating, could we then get those generated things, put those together, and go, hey, can you give me a summary of the generated messages? So now Djokovic back on top. And we can publish that one. And then all these messages, if we look over here, you can see they're all coming through. Okay, so let's go back to the slides so we can just explain to you what on earth have we just been doing. It's some magic. Yeah. It's not magic. But so just to do, I mean, we probably don't need this slide because it's like bombarded. Every single like article is explaining this to you, but just at a really, really high level. So what are we actually doing when we've got a large language model? So we've got a person. They're interacting with some sort of prompt, and to get it to work well, you've got to kind of like put some work in, like tell it exactly what you want it to do. Don't just say, hey, can you write me a tennis commentary? And then the LLM goes, based on all of its training data, depending on which model it is, it will have more or less parameters. It's going to go, here's some text that I've generated based on what my prediction model thinks would be the next most likely word based on what you've asked me to do, and it will send it back to us. Okay, so that is literally, in a simplest possible sense, ChatGPT. There is way more stuff to ChatGPT than that, but at a high level, that's quite a nice way of thinking about it. So what we are doing is just tweaking that a little bit and ingesting some context into the prompt. So this is like the world of RAG, like the retrieval augmented generation. So I'm sure you've seen like 10 million articles written about naive RAG and not naive RAG and re-ranking RAG, and there's so many different articles about RAG. Our one, I guess, is slightly different because we're not using vectors at all, right? We don't need to do vectors in any way because we know exactly what data we want to get. We're not putting, the data that we're putting into this prompt is based on, well, what happened? What match are we looking at? So we're just doing a really, really simple, this is a very, very simple version of RAG, where what we're doing is we're saying, I'm going to have some instructions, and then we're going to just pull in some context, and the context is just tennis events, right? There's nothing to do, no vector search, no embedding anything, nothing like that. It's just literally SQL query, get me back some events, convert them to JSON, stick them in the prompt. It's like it's very, very simple what we've done. And where are we getting those events? Well, we're getting them from ClickHouse. So remember, we had the raw events, put them into Redpanda, and then put them into ClickHouse. And then because the user is pulling them, right, they're always pressing that button, we're pulling them through. Now, one thing that DUNITH and I were talking about is that depending if you were building a slightly different application, like one that DUNITH mentioned at the beginning, if it was pushing the text out rather than us deciding, okay, I want some text, maybe you design this slightly differently, and maybe you would introduce a stream processor somewhere in here. So maybe you use something like Quix or ByteWax or Flink, and you say, okay, the events are coming in, I'm going to just capture a window, and regardless of what happens, I'm going to generate something based on that window. Or it could be that you say every 5 events, I'm going to generate some text, and I'm going to have it on my bot tweeting things out. Right. But for us, we decided it's going to be pulling the generated text, and so we've done it. That's why we've put the database in here. And so remember, we had our sports event feed, so we've got all this raw data in here, and hopefully this is big enough, but just to explain at a high level what's going on. So we're initializing our OpenAI up here. This is the system message. So we're basically telling it in our prompt, you are a co-pilot to a person who's writing live text. We kind of tell them, we're going to give you some events about what happened. I want you to write a 1 or 2 sentence summary, pull out things that you think are interesting. And I gave it some hints. I then tried to tell it right in the present tense, because if you don't tell it right in the present tense, it writes everything in the past tense, and so it sounds really weird. So that was a necessary thing. And make it accessible to an average tennis fan. And then underneath, we've got a function, which is probably a little bit too small. Maybe I can, if I just come over to here, maybe I can just show you the
code itself.
Yeah, I can just show you the code itself and just make it a bit bigger.
Can you see the code at the back? Okay.
Right, hang on. Get rid of. There we go. Oh.
So the good thing about this is you can always go back and change the prompt as you need. So that's
yeah. So the prompt that we had, I mean, this was just me playing around with it a little bit. And you could imagine maybe we need a slightly different prompt depending on what we want it to do. We're just using one for everything. And then when we're calling it, we are using the OpenAI client. We're saying I've got a chat completion message, I pass in the system prompt, and then ask it to, and then I pass it in the user message. And the user message is just all those bits of JSON that we pass in. What we've found when playing with this is, because I guess it's reasonably, it seems to be, I think it does a reasonably good job of figuring out what that data means, given that we're not really telling it anything. We're like, here's some JSON, and it's tennis. I tried this out with Llama. So Llama is a tool that you can use, kind of like Docker, but for LLMs. So on your own machine, you can run all these different models. I tried it with the 8 billion parameter models, and they had no idea what was going on. They were just like, somebody want a set? That was nothing to do with what it does. So it seems to work. These, at least in the format that we've got it now, it seems to need one of the frontier models. I haven't tried. We only tried it with OpenAI, but we could try it with Claude. Maybe we could try it with the Mistral Large and see how close we get. But I think any of those who have maybe seen tennis scores or have an understanding what exactly does this data mean are going to do a reasonable job. But the 8 billion models, they have no idea. They just make something up. It was like Djokovic won the set 6-love, and you're like, well, only 10 points have happened. Like it definitely hasn't happened yet. But that's what we're doing. And then let me just quickly show you how are we getting the data into that function. So what we're doing, so we're using the ClickHouse Connect. So this is a client for going and querying the ClickHouse server. We're doing localhost. Again, if we were using the cloud, we'd put in like our cloud host in there. We're then executing a query, getting back a data frame. We convert that into a bunch of dictionaries, and then that's what goes in as the events, and then it converts those to JSON. So those are the parts. So Redpanda's got the events. ClickHouse is then storing them. We've got a really a SQL query, which I'll show you in a minute. That generates some events, and then we call the LLM. So those are the pieces. There's basically four parts. So remember, this is what the event looks like at the end. So we go from our raw events and then to something like this. And then this is what the retrieval queries look like. So remember, we got our points table. So this is we're always saying, I want to get the events for a match. I think it'd be really confusing if you started getting points from different matches and crossing them. That would probably be a bit too confusing. Although I could imagine, when they do the around the grounds type commentary, that would be an interesting one to see if you can figure out how on earth do you solve that. It's like, well, in the last 5 minutes, this is what happened in one match, this is another, and this is another. But I don't know I don't know exactly how you do that. And all we're doing is we're saying, we're using this now function, which gives us the time in epoch seconds. We're saying take off 60 seconds and compare it to the published time of the events. Effectively, get us all the events that happened in the last 60 seconds. So if there hadn't been anything that happened and maybe the game's going for a really long time, then they could pull out just the recent events. But more common is the last completed game. So this one's a little bit tricky. The way to read it is to look at the subquery first in here. So what we're doing is saying, find me the last point that you have where the score was finished. So that's what they use when a game is finished. And then join that back again with the points and find, well, which game was that in? And then get all the points for that game. So effectively find the last point, then find which game it was in and get all the points for that game, and then feed those events back. And so now, that's effectively what we're doing. So we're doing the ClickHouse query, get the events, put it into the LLM, and then DUNITH's going to explain, well, how do you actually go about serving this data?
Yes, Mark. So once we get the live commentary landed in live text topic, there are a lot of things you can do because you have the data in the best pub sub system in the world. So it could be Kafka, it could be Redpanda. So you have a great pub sub system. That means you can plug as much as many consumers into this, and you can do many things possible. For example, you can stream it to web app so that we can do things like BBC Sports live commentary, or you could tweet it, or you could, route it to some kind of a data warehouse or some S3 buckets. You can do some experimentation later. So it's up to you. But for the demonstration purpose, what we are going to do is we are going to live stream it to a web application that we just built. And for that, we are going to push events rather than pulling from the web app. So that's why we use SSC server sent events. So alternatively, you could use WebSockets, right? For this demo, we did SSC server using this fast API server, and then
we don't really ever have any response coming back, right?
Yeah.
If we were doing WebSockets and we wanted the client to do some sort of interaction, maybe that would make sense. Whereas here, we're just literally like, here's the events,
Yes.
and here's some more. If you've ever used Wikimedia, they use this on their recent change feed. So this is, in case you've not seen it before, this is the Wikimedia, like Wikipedia and all their properties. So they have a streaming event platform running behind this, and then they've got this hooked up to SSE, and you can see it's kind of sending me loads of events. I mean, browser's going to be really unhappy, but you can see it's sending through events. And so they have a slightly more complicated version than what we're doing. So they say, here's an event, here's an ID, and here's my data. So I'm just going to quickly, I need to zoom this back out again.
Yep.
So if I come over here, so we've created a little wrapper around the Redpanda stream. Hopefully I can do it here. And so what it does is it creates something like that. Let's see. So you can see there's the events that we had in Redpanda. And if we would, hang on a minute. If I split my, how do I, wait. So I split that and put the commentator over here. So if we generate, let's generate something else. Let's generate another message and then we'll put it, send it in, publish. Yeah, so you see the message comes in.
Yep. So this is as much as similar to, you see the live scores coming up in BBC Live or any ESPN or any sports website. So you can extend this, and you can build upon this thing.
So you see every time I put a new message, it comes up on here. Now to make this a little bit friendlier, we'll show you our last tool. So we made a little Streamlit app to consume these. So it's called Live Feed, isn't it? So if maybe I can put it here. Localhost 8582. So we can put it. So there we go.
Nice. Right.
So you can see that Streamlit app is basically just listening to the SSE server. Every time an event comes in, it renders it to the page. So we could. There we go. So yeah, that's kind of the end of the demos. So future ideas for this particular thing, and then DUNITH will wrap it up with, well, how would we, if we don't really care about sports, how can we use any of the ideas that we've talked about? So like I said, we could do automatic summaries every some certain number of seconds. Maybe we could introduce fine-grained statistics. Could we get like a stats database?
Right.
Could we do some sort of text to SQL on that so that the writer can go, I don't know, when was the last time Djokovic lost the first two sets and came back to win? Like, that would be a cool query if it could do that type of thing. If they don't have it, to be honest, a lot of the commentators have amazing statistics knowledge, and they just know, like, boom, there it is. And you're like, well, what if I don't know it? Like, or you're watching some players that you've never seen before. Like, could we make it more exciting or more interesting? Like, can we share more interesting things by getting that data out in a way that you're never going to do it, right? Like, if it's two people who nobody knows, there's no way they're going to go to the effort to make a really nice curated feed. DUNITH was always suggesting, the way I was tweaking the prompts that it came up with, he was like, well, yeah, we should store that and then see if we can make the model better. So maybe we should take a smaller model, like take a Llama 3. Could we then go and fine tune it? So we're like, well, here were the events. This is what got generated, like capture all the matches when it was used. Could we then actually save ourselves from having to use GPT-4 or GPT 3.5? Can we make like a tennis commentary tuned LLM instead? And so that's how we think. That's some ways that we could make this better. And then I'm going to let DUNITH wrap it up.
Yeah, so what you just saw is just a solution pattern, right? So you had data coming in, and then we stored it into some kind of a analytics database, and then we built a Python application to run the generation part. So that's some kind of pattern. But this is not only for sports, right? This is you can take this as a blueprint, and you can apply it to many different fields, like anything that relates to fast data, moving objects, right? You can track them, and you can ask a model or some kind of generative technology to do a summarization for you. Maybe ask him to fill the missing gaps, or maybe smoothen data. So that's the key takeaway of this tool. So this could be extended to live auction, so you can add some flair to the auction commentary. Weather updates, local traffic updates, you can always come up with some good ideas. And then, for example, you can extend this to food delivery and, like Uber Eats, like if you...
Food is almost here.
Yes, your rider is arrived, take out your MasterCard, because you can pick it up from your transaction and you can join it with a stream processor if needed, and you can add more color, more engagement in the application. That's it, folks, right?
Yeah.
And you can finish up. Yeah.
If you want to get the code, we were trying to find a QR code generator, and all
Yeah.
of them were like
I told
making
you.
us sign up. And it says, scan me. So if
Right.
you want the code,
Yeah.
it's here. DUNITH does really good writing. So if you want to read stuff about this area, real-time analytics, anything about streaming, DUNITH has a blog here. I do videos. So if you want
He's a
to
video
watch
guy.
really short videos on
Yeah.
stuff, then that's me. Otherwise, yeah, thanks for coming along.
Yep.